Welcome to an in-depth look at a recent astronomical discovery, SN 2022 NGB, a faint and slow-evolving type IIb supernova. First, let's briefly recap what supernovae are and why they are so important to science. Supernovae, or SNE, are powerful and luminous stellar explosions that provide essential clues into the evolution of stars and galaxies. Supernovae are primarily classified into two groups based on their atomic spectra: Type 1, which lacks hydrogen lines, and Type 2, which showcases hydrogen spectral lines. Now let's focus on the initial discovery and location of the supernova SN 2022 NGB. SN 2022 NGB, also known as Atlas 22 Res, was first identified by the Asteroid Terrestrial Impact Last Alert System, or ATLAS, on June 21, 2022. This explosion occurred in the spiral galaxy UGC 11380, located approximately 105 million light-years away. Initial observations in 2022 suggested that SN 2022 NGB was a potential type IIb supernova. A new international team of astronomers has provided further evidence to support the type IIb classification and clarify its properties. The new observations were led by a group of astronomers from Yunnan University in China, furthering our understanding of this unique event. The team focused on analyzing photometric and spectroscopic data to construct and model the bolometric light curve of SN 2022 NGB. By modeling the bolometric light curve with semi-analytic models, the researchers were able to estimate the primary explosion parameters. The new findings confirm that SN 2022 NGB is both faint and slow-evolving compared to typical type IIb supernovae. The early time light curve exhibited a rapid initial decline, a feature often identified as the shock breakout cooling emission in type IIb supernovae. SN 2022 NGB's luminosity is significantly lower than some well-known SNE IIb, such as SN 1993J and SN 2011 FU, with a measured peak bolometric luminosity of 776 duodecillion erg/ek. The rise time to peak bolometric luminosity was calculated to be approximately 28.5 days, which is slightly longer than what is typically observed for SNE IIb. The collected data allowed the astronomers to determine several key characteristics about the star that exploded to create SN 2022 NGB. The supernova had an estimated ejecta mass in the range of 2.8 to 3.3 solar masses. The progenitor is inferred to have had a low-mass and compact hydrogen-rich envelope with a mass between 0.03 and 0.08 solar masses. The analysis suggests that SN 2022 NGB originated from the explosion of a moderate mass, relatively compact, stripped envelope star within a binary system. Finally, asymmetries inferred from the spectral line features suggest that the explosion itself was non-spherical.